Here we're going to look at trace flow and redirection. That's to say how traces pass from one call to another. It's very useful and it's well worth learning all the rules. So here we have a flow that reads some CDPs and sections them. Well now, every time that read gets a trace, it writes that trace to an area of memory. If we like, we can give that area of memory a name. And similarly, every time that a section wants a trace, it takes that trace from memory and we can indicate from where. We can AGC the data and tell it where to find its input. And tell it where to write its output. As with most single channel routines, the output can be in place or not in place. In this case, we can section both AGC's input and its output. Now, AGC actually produces two outputs. It's got two output ports, in other words. The second output holds the scalars that it uses to AGC the traces. So we'll give this output a name and we'll section it. So now we're going to get 3 bitmaps, the input, the AGC and the scalars. And as a test, we can multiply the AGC traces by the scalars. To verify that we get back to the original un-AGC traces. So here are the raw traces. The AGC traces. The scalars. And the un-AGC'd traces. So let's close these two and flip between the raw and the un-AGC'd traces. So it looks like we've managed to un-AGC the data. Now we'll use this redirection together with the edits we saw earlier so as to correlate some vibrosize data. So here's a vibrosize file and this is what it looks like. Channel 1 of each record is a sweep, and we need to correlate these sweeps with the other channels, 2 to 25. Let's give the output a name. And we'll section all the sweeps. And all the other channels by rejecting channel 1. So we see that 16 traces went into the first section and 384 into the second. And here are the sweeps. And here are the data traces. Now what we'll do is, on loop 1 we'll copy channel 1 here. On each of loops 2 through 25 we'll copy a data channel here and then correlate it with its sweep. And similarly with the subsequent loops through the flow for the remaining records. With these multi-input routines, if input 1 is ready, then the call will execute with whatever happens to be in the other inputs. So let's see what we get. Here's the correlated data. And the uncorrelated data. Whilst we're here, we'll make a spectrum of a sweep trace. And here's the sweep, and here's its spectrum. Okay, so one last example. Here we're going to read a file of shots, but we're only going to accept FFID 1101. And here we'll read that same file, but only accept FFID 1102. One thing about read is that the various calls to read within a flow are completely independent of one another. Each is blind to the other's existence. The first read will carry on reading until it finds an acceptable trace. When it returns, the next call will take over, and it will only return when it's found a trace. So when we've reached here, channel 1 from here and channel 1 from here will be in memory simultaneously. And we could add them or subtract them, multiply them, whatever. In this example, we'll cross-correlate them. Channel 1 from here with channel 1 from here, and channel 2 from here with channel 2 from here, and so on. And we'll normalize these cross-correlations and section everything. we see that the first read only had to read 48 traces, but the second had to read 96 to get its 48. So here are the two shots. And here's the cross correlation. And that's it for the trace flow section.